Okay. Yeah, hi everyone. So in this session, we are going to discuss about ride sharing applications. Okay, which are like Uber, Lyft, Rapido, Ola, and these are the real world applications we can see it. So we are going to discuss about how it's generally functioning it, what are the components it has, what are the functional requirements, what are the functionalities it's providing it, and what are the non-functionalities it's having in behind the scene, and then generally if we want to build the application, what will be the estimation we have to do it. Okay, what is the capacity of the application we have to set it up. Okay, so that we are going to discuss about, and then what is the database design part we are going to discuss about, and the table design. Okay, so sorry, the API design we are going to discuss about what are the high level components it has, and then what are the key issues, and then what is the solution. So these are the things we are going to discuss about in this session. Okay, so let's talk about functional requirement of these kind of ride sharing systems. Okay, so generally it should provide user registration and authentication service for drivers and riders. Okay, there are two components, two stakeholders, so which are drivers and riders, and then ride booking. So riders they can search their the nearby they can search their destination location. Okay, and then they can find out their nearby drivers, and then they can give the request. Okay, ride booking features they have the applications would provide, and then real time location tracking, so for a driver and rider updates. Okay, where they are currently now, and then matching algorithms we need that, which is like assigning the driver to riders who is nearby drivers. Okay, that matching algorithms we need, and then pricing calculations. So it's a kind of dynamic surge pricing based on the estimation arrival time, based on the distance. We have to get the pricing calculations. Okay, and then we need a payment processing service, whether it's a credit card or UPI or wallet, any other payment things. That payment service processing model also we need, and then rating and the review system need for drivers and riders, and then we need some analytics service also, which is help us to keep the tracking of ride histories and trip details and earnings and reports and everything we need that. So these are the functional requirements we need in our ride sharing systems. Okay, so what are the non-functional requirements it has? So the systems would be very scalable. Okay, so it can handle millions of concurrent users, okay, at the same time. So the system is first preference is for scalability, and second is the low latency. It should be the latency is very low. We can get the updates in real time for our drivers and riders. Okay, the and then system it's highly available. System should not down at any time at any cost. The system should be resilient and fault tolerant. Okay, and highly securable, and then data of the user it should be highly protective. Okay, and then data consistency, maintain the accurate ride status across the services. Okay, and then logging and monitoring service also mean that will help us to track ride status, payment, whether it's a success payments or failure, that everything we can keep track. So these are the non-functional requirements we need. Next, what is the estimation we can do for this ride sharing application in real world application we can talk about. So let's talk about, take any one of the application which is like Uber we can take. So we can assume 50 million monthly active users we can use that Uber application. Okay, 10 million daily rides it should happen. Okay, and then I'm saying the estimation is in the global level. Okay, in all the region, all the countries level, I'm saying it. The user is going to use it, and then average ride duration it will be around 20 minutes we can expect, and then one like the replication factor for fault tolerance it will be 1.5x uh, multiplied the replica data we have to keep it for fault tolerance. When there is a server is down, we have to get the backup data or replicate data, it should be redirected. And then how many requests we can expect? One request per second per active user, so we can expect 50 million requests per day. Okay, because 50 million are daily active users, so we can expect 50 million requests per day. And storage needed for ride history, so for 5 years, so that's also we need the storage estimations, which is like 5 years we can estimate each ride recorded. We can estimate approximately 1 kb, 10 million rides per day. Okay, so which is equal to 1 kp, because 10 million daily rides we are mentioned, and then 10 million is 1 kb, it's a 10 GB per day. 10 GB per day, it is equal to 5 years, it be 18, approximately 18 TB we can expect it. Okay, so this is the estimation we can calculate it. Okay, so what are the database designs? What are the tables we need? Okay, so the tables wise, we need a user table, so that will keep user details with whether they are like what is their roles. Also we can keep the name, email, phone number, what is the role, whether it's a rider or driver, that also we can keep it. Okay, and then we can keep separate drivers tables also, we can keep it. That will help us to their current location, whether they are available, they are offline, that everything, the user ID, what is their vehicle ID, and then the rating, how much they rating they have, where they are currently, and then current status, they are available on trip or offline, that everything we can keep it in the drivers table. Okay, and then rides table we can keep it in the rides table. We can keep ID, who is the rider ID, which is a user ID, who is the driver ID, that's also user ID. What is the start location, end location, what is the status, whether it's requested, accepted, ongoing, completed, or cancelled. What is the fare? What is the fee for this travel? And then when it started, whether it's when it's complete. This everything we can keep it in the rights table. Okay, and then payment table also we can keep it in the payment table. What is the ride ID? User ID, amount, what is the status, whether it's completed, pending, or failed, what is the payment method, cash, card, or wallet, what is the transaction ID, we can keep it, and when it's created. So these are the tables. It's enough to build MVP of ride sharing applications. Okay, so what are the APIs we need? So in API wise, so we can categorize in three groups, which is the user API, user relevant APIs, which is like a register a ride, user register, sorry, register rider, and register driver. Okay, and then login API we need that, update the location APIs we need that. Okay, and then ride APIs, request a ride. Okay, so user can rider can request for a ride and accept, right? So driver can accept it. Okay, and then when it's completed, then we can complete API and cancel it. These are the rights API win. And then payment, make a payment API, check the status. These APIs all we need. So these are the APIs are enough to keep the MVP of application, build the MVP of application. And then what is the high level components we need? Okay, so the high level components, we need a API gateway that will handle the authentication and request routing. We need a user service that will manage riders and drivers details. We need a ride matching service, okay, that will assign nearest drivers using geospatial index. Okay, ride matching, and the real-time tracking service, we can use WebSockets, we can use it, that will stream the riders and drivers updates. The pricing engine that will calculate the ride fare dynamically. And payment service, we need that process transaction via Stripe's PayPal. The notifications send the ride updates via push notification. These are the high level components we need that. And then what are the key issues as how we can remediate it? So real time location updates, one of the issue. How to efficiently update and retrieve the driver locations? What is the solution? It would be we can use Redis with GeoHash for fast location indexing. We can use it. So and then sockets for real time updates. These are the things we can use it for effectively updating the driver location. Okay, and then ride matching algorithm. So we have to assign the specific rider to specific user based on their location and availability. Okay, how quickly match the rider with nearest rider with nearest driver. Okay, so use quad tree or KD tree for fast geospatial lookups. So these are the algorithms are available. So we can use it to pick up fast nearest driver is available, and then red is geo index for quick nearest driver search. So these are the things we can use it for ride matching algorithm. Okay, what is the price calculation? How to dynamically calculate ride fares? Okay, so the solution we can use Kafka or SQS to stream demand data in real time, and machine learning models to predict the demand spikes. So that will help us to predict the price for the specific ride. Okay, the payment processing and fraud prevention. So how to handle millions of transactions securely. Okay, so we can use tokenized payments. We can use tokenized payments with PCI compliant gateways, implement the fraud detection models to flag suspicious activity, implement detection models to flag suspicious activities, anything happened in the payment process. Okay, and then high availability and scalability is one of the issue. How to secure the system run 24/7 with minimal downtime. So we can set up multi-region AWS deployment for redundancy, load balancer, application load balancer, Nginx for distributed net traffic, microservice architecture for modular scalability. So these are the things we can do it to solve the key issues. Okay. So now let's go to the high level architecture. Okay. Here we can see two stakeholders. One is driver, another one is riders. Okay. So here there are then they communicate with public facing. So these are the interfaces to connect with the uh, ride sharing system. So generally they have to install mobile apps. Okay, then that mobile apps will communicate with these services. Okay, so we have a these are the public facing service, which is like a route 53, CloudFront, and AP gateway. Route 53 for a DNS service, so for a domain name registrations. And then for example, your application is uber.com. When you enter uber.com, so uh, it will get route 53 will send the get the request, and then it will redirect it to the next service, like internal service, it will redirect it to it. So this will be the first entry point. Okay. Then we have a CloudFront, that is the edge computing service for a CDN. Okay. So and then we have a API gateway. Okay. So in that API gateway, that will communicate with various services, various category services. So we can integrate API gateway with web application firewall for security concern. Okay, and then in the request it comes, we can integrate it with cognitive user pools and secret manager. That will make sure only authorized user can make the request. Rate limitings and everything we can configure in the API gateway. Okay, so we have a authentication security service. It has security managers and cognitive user pools. So it will create the user and store their credentials and everything. We can store it. Okay, once everything is success, if the user request is valid user, then it will send the request to core microservices. So these services, it has user service, user management, ride matching service, notification service, okay, and a ride service, ride management service, and payment service. Okay, so these are the different categories. It's that the request it will be redirected to it. So okay, user service, it will keep users which are riders and drivers details. Okay, and ride matching service, it will has dynamic pricing service and ride matching engine. So which is which rider is currently available. Okay, where they are currently located, what is the requested locations. Okay, so what is the nearby location, everything is has been calculated here. And then the ride matching service, it will assign the particular driver to specific a rider, and then price calculation service also we have. So that will provide the dynamic pricing for the specific destination. Okay. And the ride match service, it will keep the ride details and everything, it will keep it. And then payment service, we have a payment processing, and then a fraud detection service also we have. It will help us to find out some suspicious activities in your transaction. Okay. So these are the services we have, and then we can integrate the service with we have some external services also we need that, which is map integrations and payment gateway service. These are the external services we can integrate it. So next we have some another categories of services we have, which are real time services, which are like the request it comes, we can integrate it with the WebSockets. So it will help us to send the real time updates, and then location processor, everything we can get it. Okay. And then the ride request, and then the notification and location details, everything we have, we can store it into the uh, SQS to process it, SQS, and send the notification to the specific categories of services. So for example, we can see a ride request, everything comes from API gateway, and then it's sending to the SQS. Okay. And then it's sending to the ride matching engine. Okay. So once that is done, right, the notification has been sent it to here, and then it will send the messages to back to the system. Yeah, okay. So then next, let's check the database layer. Okay. In data layer, we need a various service, which is a SQL, NoSQL, and S3 service also we need that. So analytics and history purpose, we need a data lake that will keep all our history, the ride histories and everything. It will store it. We need a S3 bucket, and then trip history that we can store it into the DynamoDB. Okay. And then the logs and everything, we can store it into the uh, S3 bucket. For example, 5 years we have to keep the data. Okay. Then we have to store the data into the data lake. Okay. So then for relational tables, we need that will help us to write and payments store, and then users and accounts details, everything will be stored into the relational database. And then we need some caching and real-time data. We can use Redis geospatial cache servers, we can use it. Okay. So some real-time analytics, real-time processing, the price calculations, everything we need a separate service, analytics and ML service. Okay. So it will get the request from ride matching engine, the analytics stream, it will send it that, and then stream processing, it will take that. Any data is there, it will be stored into the analytics storage. And then we have a SageMaker model that will help us to predict the on-demand price for the specific ride. So that will help us to estimate ETA, estimate a time arrival, everything. It will help us to do it. So then it is done, then it will send the details to the map integration or payment gateway, or back to the ride matching service, it will do it. Okay. And then we can keep some business intelligence dashboard that will we can view all the rides, and then we can create the charts for analytics. So yeah, this kind of categories the service we need. The public facing service, which is edge computing service we need, and authentication security service, real time services for get some real time updates, and the messaging service, microservices for core microservices for ride managing, user managing, price calculations, and ride matching. And some of the external service also we keep it. And database layer, we need various categories of databases we need, which is analytics and history, and relational databases, and caching and real-time data. And then we need analytics and ML categories of service also. We need analytics stream, kinesis stream processing, and analytics storage. We need that, and on-demand SageMaker models also we need that. That will help us to uh, right, like get the data, estimated the price or duration, everything. It will help us to estimate it. So these are the services we need for ride sharing application. Okay. I hope this session is really useful. Okay. So we will see you in the next upcoming session. Yeah. 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 Thanks everyone. Thank you.